guys, we're back here. Just math, y'all. Calc 1. We are doing 2-6. We are doing continuity today. All right, we're going to have at least 2 videos, maybe 3 videos here for this 2-6. Okay, here we go. All right, continuity. Basically, in a nutshell, a function is considered continuous, or it has continuity, if there are no breaks, gaps, or jumps in the function. And we want to know if it's continuous at a particular point. And so if it is continuous at a particular point, it has 3 checklists. We have a continuity checklist. The first thing we have to decide is the function defined at that point? If it is, we move forward to the next one. Next stipulation is the limit as x approaches that point has to exist. Okay? And then third, the limit that you get must be equal to the value of that function. So the value of f equals the limit of f. Okay? So there are 3 main objectives for this particular section. First one is to determine if a function is continuous at a point from a graph and an equation. We'll do that in this video. And then in video 2, we will look at intervals of continuity. And then if we need another third video, we will do the intermediate value there on that one. So let's jump in. Okay, so don't forget your checklist. Here we go. All right, so we're going to try to see if this function is continuous at each of the x values. And it's obviously that this function has gaping gaps in it. So we know that it's not continuous. Okay, so let's just make sure we understand our checklist and understand why each point is not continuous. So for x equal 1, if we look at x equal 1, we see that there's a hole right there. So that defies the first of the checklist. So f of 1 is not defined. We don't have a number for f1. So that's why it's not continuous, because it violates the first one. F of 2, however, is defined. It is defined. F of 2 is defined as 3. Okay, so f of 2 is defined. But what about the limit? So we move on to step 2, or checklist number 2. So now if we look at the limit as x approaches 2 of this function, okay, so when we look to the right of the function and it's approaching 1. And when we look to the left, it's approaching 1. And so the limit is 1. So this one is not continuous because they're not the same. Let's look back. First, it's got to be defined. The limit's got to exist. And then those 2 values have to be the same. So, not continuous at 2. And we know that. We can see that it's got a gap right there. All right, for 3, okay, again, f of 3 is defined. It's defined as 1. The limit to the right is 1, but the limit to the left is not 1. Okay, so the limit for this one does not exist. So it's not continuous. Okay, so now x equals 4. So x equals 4. F of 4, here's 4, is defined. There it is. It's 2. And the limit is also defined. From the right, we get 2. From the left, we get 2. So the limit of the function is 2. These are the same. So the function is continuous at 4. That's continuous at 4. All right. So now I won't do the other 2. I think you kind of get it. It's not continuous at 5. It's not continuous at 7. And it is continuous at 6, even though I didn't do that. I wrote that in there. It's not continuous at 5. It's not continuous at 7, but it is continuous at 6. Okay, so now we're going to do the same idea with a function from a function that we have here. Okay, so we're going to do our checklist once again. So we'll do f of negative 5. Well, I can't plug in negative 5. Look at my denominator. If I have a negative 5 squared plus 5 times negative 5, I get 0. So it's not defined at a equal negative 5 or x equal negative 5. So it's not continuous. So now let's think this next one's going to be a little easier, or no, not easier, a little trickier, because we have a piecewise function. So let's not forget what a piecewise function means. Okay, and so here we have a is negative 1. Okay, so we want to do f of negative 1. Well, it is defined. It's defined right there. If x is negative 1, then the function value is 2. So it is defined. So then we've got to do the limit. Checklist number 2. The limit as x approaches negative 1 from the right and from the left. Okay, so we have x squared plus x, or x plus 1. I can't plug it in, but I think I can factor, so let's try that. Yes, I factored it. Okay, and that's going to allow me to cancel out. So I get x, I can plug in. So my limit is actually negative 1. But is it continuous? No, it's not continuous. It's not continuous because the value of negative 1 is not equal to the limit as x goes to negative 1. That's why it's not continuous. Okay, so that's your checklist. Make sure you go through each item of your checklist. Make sure that you are clear on this. Yes, I know you can look at the graph and know that it's, and know this, that, and the other, but we want to make sure we do our checklist. Okay? All right. It's just math, y'all. Come back for video number 2, where we look at determine the intervals of continuity on a function.